Welcome back, students. This in this section, time series analysis, we'll try to understand how to calculate the trend and all. Now, this is very important when we talk about the forecasting. Now, time series analysis is one of the major devices of the tool for the forecasting of the data, and we will explain we'll explain that taking lot of examples later on. But what is exactly time series? Now, time series is nothing but seeing the name of the time series. You can understand that we'll get lot of data based on certain variable. Okay, it may be sales, it may be marketing, it may be demand, it may be production, or whatsoever, quantity, and so on and so forth, right? So we'll be getting lot of data chronologically based on the year, month, day, all of those things chronologically. The moment we get that, then we call it time series. And based on that time series data, when we do the analysis, then it is called time series analysis. Okay, now it is the collection, it is collected on a variable or the variables. Now, variable or variables is nothing but rainfall, production, demand of the industrial product, production of the rice, sugarcane, it can be import export of the country, population, etc., so on and so forth, right? So this is the collected on the variable data which is collected at different time epoch. That means hours, day, month, year, whatsoever you can say, right? Quarter. You are collecting that data based on these variables and all over the period of time, right? Such a data is called a time series data, arranged and presented in a chronological order. That means over a period of time. It may be top to bottom or bottom to less, whatever. It may be the the least means 2000, starting from 2010 to 2020, or it may be 2020 to 2010. That's okay, but we will try to use the chronological order based on that. And now this is called the time series data, and the analysis which we will be doing based on the data, this data we'll call it time series analysis. Now, what is the formula for that? Before that, let me tell you the model of this. Now, this is the time series, and the models, there are two models, adaptive model and the multiplicative model. Now, adaptive model or the multiplicative model, and the categories and the components. We'll explain that. Now, what is the adaptive model formula? It is nothing but Y, which is the time series analysis data, equals to T plus C plus S plus R. Now, this is adaptive. That is the reason I have mentioned plus. If it is multiplicative, it will be T multiplied by C multiplied by S multiplied by R. Okay, I will come back to that. But what is all about this T, C, S, R? T is nothing but trend variance. C is cyclical variance, seasonal variance, S is represented for seasonal variance, and R is represented for random variance. Correct? Now, this is the values which we'll be getting based on this time series data. If we apply here, we'll be getting a time series value which can be used for the prediction or the forecasting for the data. As I said, the multiplicative, if I use the multiplicative model formula, then it will be the trend value, time series value is nothing but the trend variation multiplied by cyclic variation, multiplied by the value of seasonal variation, and multiplied by the random or irregular variation. But what are these things? Now, S stands for secular trend. Okay, seasonal variance, and something is called secular trend, which is a long-term movement. We need to understand, and this is nothing but the categories of the components. Clear? Now, under categories and the components, we get secular trend. What is the secular trend? Which is a long-term movement. Okay, long-term changes per capita income, technological improvements of the growth of the population, changes in the social norm, sales, whatsoever, which is a long-term effect, right? Second is seasonal variance. Seasonal variance is nothing but which is dependent on your season. So sales might go up during the Diwali because you get bonus. Your consumption goes high. So this is during Diwali and the Christmas. Your may be possible that your sales go high, or sales of restaurant and eateries may go down during Navaratris, Ramzan, or other reasons. So these are the seasonal variances, right? Something is called cyclical variance. Now, cyclical variations is nothing but due to ups and downs. Okay, due to ups and downs recurring after a period from season to season. It has four phases, like I say the prosperity, which is boom. That means your company is doing very good, boom. Then it will come down to recession, depreciation, okay, and then it will recover. So there are four phases accordingly. I'll explain you in the next slide. Okay, and all these phases together may last from 7 to 9 years. Okay, it may be slightly less than that. Let's take an example, cyclical variance. I can give you an example that all the time, if you are in a business, you cannot think that your business will go high, 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 high. It will be a prosperity level, then it will go down, decline, deep recession, where you will struggle huge, okay, and then again you will recover. That is the cyclical variances. And the fourth one is random or irregular variances, which means nothing but, for an example, these variances are due to random external variables food, like foods, wars, famines, earthquake, coronavirus, which affected our global economy. Okay, strikes, lockouts, epidemics, anything. Okay, pandemics, anything. It can be the random or irregular variance which you cannot predict, which is not under your control. So these are the four types of categories of the components are there. Now let me take an example and explain you a little bit more. Let me explain you a little bit more on this cyclical variance and the secular trend. Think that think that this is the sales data. This is the sales data of Coca-Cola company. Coca-Cola company sales data. Okay, think that I am assuming this is to 2010, 2015. Just giving example, 2018, 2019, and 2020. Okay, just giving an example. Okay, so this is, let's say, the sales data. Now what is this? What is the cyclical variance? Cyclical variance is like this. Okay, what is this? This is the cyclical variant. Okay, this is the sales data. Sales. What is the cyclical variant? Now cyclical variant has like this. Think that this is your prosperity. Okay, your growth mode. Then you are going back to depression, recession. Recession is very deep, that is deep recession, and then you are recovering up. Correct. So this is nothing but growth or prosperity. This is decline. Decline is nothing but, I am naming it, terming it as recession. This is nothing but deep recession. Okay, and this is nothing but recovery. Again you are recovering up. So this is the cyclic process. It will happen. It is the cyclic process, day in day out, year after year, or maybe decades after decades. It will go like that. So this is the nothing but the cyclical variance and all. Now when I'm talking about the secular trend, that means long term changes in the capita of the income of the sales, I will say, let's say this is the straight line I'm putting from first point to last point. This straight line represents the secular trend. Secular trend. Clear? Which means it's a long-term effect, long-term changes in the sales. Whether it is small or big, starting from here to last point, if I'm joining this line, okay, these 2 points, I will get a straight line, and that represents the secular trend. Okay, hope you have understood this in depth, and you can apply this logic in your, when you are doing the business analysis related to problem of your business, or when you are applying that into data science. And this is a good technique for the forecasting. Right, now in the next section we'll be taking some problems, okay, and we'll try to solve using this formula.